The factory environment continues to unfold as the camera moves deeper into the production line, revealing a carefully controlled space where every movement is deliberate and synchronized. The freshly processed banana pieces glide forward on polished conveyor belts, their speed constantly adjusted by embedded sensors that monitor spacing, alignment, and volume. Nothing here is accidental. The machinery communicates silently through digital signals, ensuring that no piece moves too fast or too slow. The atmosphere feels calm despite the immense scale of production, a testament to how automation replaces human chaos with mechanical precision. Overhead, ducts circulate filtered air, maintaining stable humidity and temperature so that the product remains uncontaminated and structurally intact as it progresses. As the bananas advance, they enter enclosed chambers designed specifically for product stabilization. Depending on the final intended use, whether drying, freezing, or packaging as a fresh-cut product, the system automatically redirects them. The chambers hum softly, regulating heat with remarkable accuracy. Steam may briefly surround the pieces, not enough to cook them fully, but sufficient to neutralize enzymes that would otherwise cause discoloration or spoilage. This moment is crucial because it directly affects shelf life and visual appeal to factors that heavily influence consumer acceptance in global markets. Once stabilized, the banana pieces are gently cooled. Cold air circulates evenly, preventing condensation from forming on the surface. This step ensures that moisture levels remain balanced because excess water could compromise texture, flavor, or packaging integrity later on. The machinery handling this phase is designed to avoid sudden temperature shocks, which could damage cellular structure. Everything is gradual, smooth, and meticulously calculated. The production line then transitions toward the packaging zone, an area that feels almost clinical in its sterility. Transparent protective shields surround the conveyors, while ultraviolet sanitation lights operate intermittently to reduce microbial presence. Robotic arms, equipped with soft-touch grippers, pick up portions with flawless consistency, placing them into precisely measured packaging trays. Each movement is identical to the last, eliminating variation that would otherwise occur with manual handling. The robots work tirelessly, unaffected by fatigue, ensuring uniformity across thousands of units every hour. Packaging materials arrive on a parallel line, fed automatically into the system. Trays are formed, inspected, and aligned before receiving the product. Any tray with a microscopic defect is instantly rejected, diverted before it can cause issues downstream. The banana pieces settle into their containers, arranged in a way that maximizes visual appeal while minimizing wasted space. This careful arrangement is not just aesthetic. It also optimizes transportation efficiency by allowing more units per shipment. Once filled, the packages move forward into sealing stations. Heat sealing or vacuum sealing mechanisms engage depending on the product specification. The sealing process is swift yet controlled, ensuring airtight closure without deforming the contents. At this stage, the environment becomes even more regulated, with positive air pressure preventing external air from entering the sealing zone. This barrier is essential for preserving freshness and preventing contamination before the product reaches consumers. Labels are applied immediately after sealing. High-speed printers generate batch numbers, production dates, expiration details, and traceability codes in real time. Cameras verify that each label is correctly placed and fully legible. If even a slight misalignment is detected, the package is removed from the line. This traceability system allows every unit to be tracked back to its raw material source, a critical requirement for modern food safety compliance and global export regulations. Following labeling, the packaged products undergo a final quality assurance scan. Advanced imaging systems check seal integrity, internal product arrangement, and overall appearance. These inspections happen faster than the human eye can follow, yet they catch imperfections with extraordinary accuracy. This redundancy ensures that only products meeting exact standards continue onward. The accepted packages are then grouped and prepared for secondary packaging. Robotic systems assemble cartons, load them with precision, and seal them securely. Each carton is weighed to confirm that the contents match the expected specification. Any discrepancy triggers an alert, prompting immediate investigation. This level of oversight minimizes losses and ensures customer trust is maintained. From here, cartons move into automated storage areas where temperature and humidity are carefully controlled. Tall robotic stackers organize inventory efficiently, placing cartons in optimal positions based on shipping schedules. The warehouse operates like a living system, constantly adjusting to incoming and outgoing flows. Orders from distributors are processed automatically, with the system selecting the correct cartons and routing them toward loading bays without human intervention. At the loading docks, autonomous vehicles transport the cartons to waiting trucks. Timing is precise, reducing idle periods and conserving energy. The entire logistics chain is integrated digitally, allowing managers to monitor operations in real time from centralized control rooms. Data streams continuously, providing insights into efficiency, performance, and potential areas for improvement. Beyond the visible machinery, the factory's intelligence lies in its software. Algorithms analyze production data, predicting maintenance needs before breakdowns occur. This predictive maintenance reduces downtime and extends the lifespan of expensive equipment. Energy consumption is also optimized, with systems adjusting power usage based on demand, contributing to sustainability goals. Waste management operates quietly in the background. Banana peels and organic residues collected earlier are processed separately. They often converted into compost, animal feed, or bioenergy. Water used during washing stages is treated and reused, significantly reducing environmental impact. These practices reflect a shift towards circular manufacturing, where byproducts are reintegrated rather than discarded. Although automation dominates the process, human presence is still vital. Technicians oversee operations, intervene when anomalies arise, and fine-tune systems for optimal performance. Their role has evolved from manual labor to skilled supervision, requiring technical knowledge and analytical ability. This collaboration between humans and machines defines the modern industrial landscape. As the production cycle continues uninterrupted, the factory demonstrates how technology transforms raw agricultural produce into standardized, globally distributable goods. Every step, from intake to shipment, is connected through data, engineering, and design. What might seem like a simple product is actually the result of countless decisions, calculations, and innovations working together seamlessly. And the line keeps moving, hour after hour, day after day, producing consistent results with minimal variation. The video ultimately showcases not just a factory, but a philosophy of precision, efficiency, and sustainability, illustrating how modern industry meets the demands of scale without sacrificing quality or safety. The rhythm of the factory never truly pauses, and as the production line continues its steady motion, the focus subtly shifts toward the systems that keep everything balanced and responsive. Deep within the infrastructure, networks of sensors constantly measure temperature, pressure, vibration, and throughput. These measurements are not simply recorded. They are interpreted in real time by control systems that adjust machinery behavior almost instantaneously. If a conveyor begins to move a fraction too fast, it slows itself. If a motor draws more power than expected, the system compensates or flags it for inspection. This silent conversation between machines forms the backbone of operational stability, ensuring that small deviations never grow into costly disruptions. Energy management plays a crucial role in sustaining such a massive operation. Power is distributed intelligently across the facility, with high-demand sections receiving priority while idle areas reduce consumption. Lighting adjusts automatically based on activity, and motors operate at variable speeds instead of running at full capacity unnecessarily. Heat generated during processing is often recovered and reused elsewhere in the plant, further improving efficiency. These measures not only reduce operating costs, but also align the factory with increasingly strict environmental standards demanded by global markets. As production continues, data accumulates relentlessly. Every processed unit contributes information to a growing dataset that reveals trends over time. Managers can identify which machines perform best under specific conditions, which stages are most sensitive to variation, and where minor adjustments could yield significant improvements. This data-driven approach replaces guesswork with evidence, allowing decisions to be made with confidence. Over weeks and months, the factory effectively learns from itself, becoming more refined and resilient. The integration of automation also enhances safety throughout the facility. Dangerous tasks, such as heavy lifting or exposure to high temperatures, are handled entirely by machines. Safety barriers, motion sensors, and emergency shutoff systems stand ready to respond instantly if irregular movement is detected. Human workers operate in designated zones where risk is minimized, focusing on monitoring, maintenance, and optimization rather than physical strain. This shift not only reduces workplace injuries, but also improves morale and job satisfaction among the workforce. Communication within the factory extends beyond its walls. Supply chains are digitally connected, allowing raw material suppliers to adjust deliveries based on real-time demand. If production increases, incoming shipments are scheduled automatically. If output slows for maintenance, suppliers are notified in advance. This synchronization reduces storage needs, minimizes spoilage, and ensures that fresh produce enters the system at optimal intervals. The factory becomes part of a larger ecosystem, responsive to both upstream and downstream partners. Quality assurance remains a constant presence throughout the operation. Even after products have been packaged and stored, samples are periodically selected for laboratory analysis. Texture, moisture content, microbial levels, and appearance are tested to confirm compliance with specifications. These results feed back into the production system, reinforcing standards and highlighting areas where calibration might be required. Consistency is not assumed. It is continuously verified. As finished products leave the facility, the focus turns toward distribution efficiency. Logistics software determines optimal routes, balancing delivery speed with fuel consumption. Trucks are loaded according to delivery sequence, reducing unloading time at destinations. For international shipments, documentation is prepared automatically, ensuring compliance with customs, regulations, and import requirements. This level of preparation reduces delays and preserves product integrity across long distances. The factory's design also anticipates change. Modular machinery allows production lines to be reconfigured for new products or market demands. If consumer preferences shift, adjustments can be made without dismantling the entire system. This flexibility is critical in a competitive global environment, where adaptability often determines success. The facility is not a static entity, but a dynamic platform capable of evolving alongside industry trends. Underlying everything is a philosophy of continuous improvement. Engineers regularly review performance metrics, seeking marginal gains that collectively produce significant results. Even a small reduction in waste or energy use can translate into substantial savings at scale. These incremental improvements accumulate over time, reinforcing the factory's competitive edge and sustainability credentials. The human element remains central despite the dominance of machines. Training programs ensure that staff stay current with technological advancements. Operators learn to interpret data dashboards, troubleshoot complex systems, and collaborate with automated tools. This emphasis on skill development transforms the workforce into active participants in innovation rather than passive observers. The video continues. It becomes clear that the factory represents more than just efficiency. It embodies a broader shift in how food is produced and distributed. Traditional manual processes give way to precision-engineered systems capable of meeting global demand without compromising quality. The seamless flow from raw material to finished product illustrates the potential of technology when thoughtfully applied. The production line carries on, unwavering and methodical, reflecting a balance between speed and care. Each banana that enters the system follows a carefully orchestrated journey, shaped by countless design choices and technical considerations. By the time it reaches the end, it has been transformed not just physically, but symbolically into a product of modern industry. Shaped by data, automation, and a commitment to excellence. And still, the movement does not stop. The factory continues its cycle, responding to demand, adapting to conditions, and refining its processes with every passing moment, demonstrating how the future of manufacturing unfolds quietly, efficiently, and relentlessly through systems like these.